So here's our ball turner all put back together with the extended upright. Gives me it's good clearance for the tool post. And my tool post nut's a little taller than normal. I have my I can call it the double boost special. I copied the one I saw in John Mills' videos because I just had to have one. And anyway, I did that a while ago. I did recently change tool posts. I got rid of the original Chinese one and put a Dorian, which is it's U.S. made. I think they're in Texas, and it is just a world more precise than the old one. I did some repeatability tests, and it will easily repeat within a tenth, swapping tools out. Anyway, our things, our holders in, our stops on. It works exactly like it should, of course, because it's just a flat plate. It did have an effect I wasn't expecting, I didn't even think about, which is going the other direction, which actually is kind of nice because it stops it just past halfway, so I can actually just swing back and forth for turning a hemisphere, and obviously flop that out of the way if we want to go all the way around. This was made in the UK. It's SE Repton. I don't know if you pronounce it Repton, but they actually have initials on it on the website, SE Repton. So anyway, it uses a DNMG bit. That's the one that came with it, and it worked fine for what I used it on last time, which I think was brass. But copper is it's a pain in the butt to machine. So I have some what they call highly polished inserts that are made for non-ferrous materials. So I'll put one of those in there. And here's show you our hunk of metal. So here's our hunk of copper we're going to be playing with. I actually did put it in last night just to take a light cut and test a grooving tool. This is actually going to be turned off, so it doesn't matter. But this is one of those times when having a lathe with a fairly large bore is nice. This is 1 3/4 copper, and this lathe has a 2-inch bore, so I can slide it all up into the chuck except for the part I want to work off, cut it off, stick it out, do it again. And then when this is all done, we'll have to turn it around and drill and tap on the other side, and we'll make a little fixture for that. So let me get things turned around. Thought I'd show the difference on the inserts really quick. So this is one that came in. It's like I think it's a DC MX. You know what? Let me look on the box so I don't say something stupider than normal. So it's a DC MT. Which it's it's titanium nitride coated. It's mostly for cutting steel, and it's good general purpose. It's got a little chip breaker on it, but if you can see this one, it's really sharp, really sharp, very highly polished, which is good for aluminum and copper, which tend to be sticky. And I'll use some WD-40 on it as well. But this they'll interchange, and that's what we're going to be using to do our cut. Okay, so we got our piece mounted up, different tool. This is actually a CCGT type of insert. It's the same sort of thing as the one I just showed. It's very highly polished. It works great on aluminum, copper, things like that. So this is 1.75. Our finish dimension is 1.7. So we got to take a little bit off, and I had taken a test pass last night just to see. So I think we're at about, looks like at about 730, almost 735, 734 and a half. So we've got to take off 34. Copper, like I said, for me, cutting it fast has just never been very good. So we're going to take 20-30 thousandths at about 500 RPM. Oh, the lathe sounds kind of noisy. It might be just because it's cold. Gears aren't grinding, nothing's bound. It's probably just cold. It is February, so it's not running on center, which is fine, because we got to take some off anyway. So we'll just start there. Just let it take a skim and turn the feed rate up a little bit. See where we're at. WD-40. For me, I get better results turning copper at a fairly high feed rate, which it is. I don't know what it is exactly, I'd have to look. And not a high RPM, even though it's non-ferrous. So that way it leaves a decent finish, no chatter. We need right at 2 inches, so that's gonna be good. We'll just go to our little mark where we stopped. And that'll become important here when we go to put the grooves in. I'll show that in a minute. This isn't cleaning up all the way, so hopefully we got enough to get it round. And we'll measure on the part that it is hitting on both sides just to see where we're at. I didn't take very much off, so we should have plenty. So yeah, we're at 727. So we'll take 20 thousandths off. That cleans it up nice, and we'll hit our size. I mean, these are just decorative feet, so the size doesn't matter a lot, but because we have to make a little fixture to hold these in so we don't get jaw marks all over them after they're grooved, size is going to be fairly important. I'm going to shoot for basically +0, maybe +1 to -2 or 3, pretty close, within a couple thousandths, which shouldn't be hard to do. And if you are ever turning copper or doing anything with it, and you can see that it's got a lousier finish now that I'm taking 20 thousandths even. Copper has extremely high thermal conductivity, which means that it gets hot easy. So you have to let it cool off if you're really shooting for something precise. I mean, this isn't hot yet because we're not taking very much. And turn the ball on, it'll probably get a little warmer. So we're at 709 and 5. So we need 9 thousandths off of there. I do want a good finish. So I'm going to take 6. And then we'll just take a light pass for the end. Just using WD-40 on it. Like I said, that groove that's on there now is going to get turned off when we make the ball in. Yeah, we're getting a lot nicer finish now. So I've never tried to turn a ball end on copper, so that'll be hopefully not too. Hopefully there won't be any excitement involved. But we'll see. Okay, I think that is a good 2 inches long. Just a hair over, which is perfect. So, let's see where we are. We should be about 3 or 4 over. Yeah, we're at 702 and some change. Let's see, make sure we're not cutting the taper. No, we're good. Well, pretty close. It's cutting a little taper. Lathe must have settled over the winter. I have to re-level it one of these days. We've got about 1/10. So anyway, we're going to go 703. I'm just going to take 3 thousandths and call it good. That'll be good. I'm actually going to use the DRO for that. 2, 3. Looks like we got a real nice finish. that's where those highly polished, sharp inserts really work good, is stuff like this. Wouldn't want to use it on tool steel, probably. Might work, don't know, I haven't tried, but works really good on copper, aluminum, brass, that sort of thing. Okay. Just going to pull out so we don't get any marks. Oh yeah, that's going to polish up real nice. Check our size. Yeah, we're about 2/10 off. Yeah, about 2/10 over. I'd say that's within tolerance. So, something like this, the order of operations really matters. So, the print shows, which we're going to put a ball on this end, and it's got 3/32, which is 93 thousandths grooves, with equal spacing. Every 187 thousandths, we'll put another set of grooves in there. But they start from this end. So what we're going to do, because once the ball's cut, we won't have a good reference. Start here and go over and find where our end is going to be. And then when we actually cut this off and face it afterwards, we can measure the width left over from our grooving operation and get the right length that way. So there's a couple ways you can do this. I did a thing last week, and I just used this parting tool, and it works okay. It's high speed. I sharpened it up, honed it, and it works good. But because of the way these holders tend to chatter, so I actually, because I have a few of these to do. Oh, there goes the phone. Hang on. Okay. So instead of the parting tool, I bought a grooving tool because I have a feeling I'm going to have more of these to do, so I think it was worth the investment. This one's just from Shar's, but seems okay. It has the insert measures 86 thousandths wide, and so if I want 93, I'll have to move it over a few thousandths. That's no problem. Our groove, I used some pin gauges, and let's see which one's which here. My old halfway blind self, let's see, 86, 87, yeah. So an 87 thousandths doesn't quite reach the bottom, and an 86 thousandths does. So that, I'm going to call that the width of the groove, which is good. It matches the insert, so we're good there. So what we're going to do is put this in and just touch off on the end, and then use our DRO. I'm going to go over so that it's 2 inches exactly to the end, and then come back in our 93 thousandths. So it's just touching. So we'll zero the DRO. Oh, zeroed the wrong axis. Well, let's try that again. Okay, so it's just touching. So we're going to go over exactly 2 inches, because that's going to be our finished length, and we're going to use this as a reference later. We're going to cut it off slightly longer than 2, but we want it exactly 2 for the reference. So there we are. So, and we're going to zero that axis again, the Y. So because our first groove starts 93 thousandths from the end, and we're using this as the end, so we're going to come over to the right. .93. Come on, give me that last tenth. There we are. So we come over 93. So we'll just cut this groove, and then we have to move it over 6 thousandths to make it the right width from 86, or 7 thousandths I should say, from 86 to 93, and the width isn't super critical, it's just cosmetic. We just want them to all look the same. And then we'll reset 0, go over 187 or 186, and do this until we get enough grooves. Looking at the print, we need 1, 2, 3, 4, 5, we need 6 grooves. So we're gonna do this 6 times. And slow the lathe down. They're 50 thousandths deep. So once I touch off on the depth, we'll 0 that direction and just keep going. So we've moved over 93, we're ready for the first groove. Carriage is locked. We're gonna take this down to, I don't know, 300 RPM or so. Hope it won't chatter much. We'll just touch it. Okay, we're touching. Gonna set that on 0. Put some WD on here. And just, because even this, it's trying to chatter. You can hear it. It's kind of like a parting tool. It's best to just keep feeding and not let it stop. Okay, there's some, within a, so that's 25. So we got to go 100 thousandths on OD, which is 50 thousandths deep. And then right, that is just right there. So you can hear it trying to chatter. So we're just going to stop it right there. Back this out. We're going to move it over 7 thousandths to where our Y reads exactly 100. Lock the carriage, and then we're just going to take this is basically just going to take 7 thousandths off the right side until we get to depth. Which is right there. So we're good there. Back it out. Reset our Y. We go 186 right there. Lock it off. And we're going to do this 5 more times. So those look pretty good. They look very nice and evenly spaced. And that's the important part. I think we're going to be good there. Like I said, we're going to use the inside of this to the end later as our measurement datum. So getting them from here over is pretty important. So now comes the fun part. Let's try out the ball turner. Let's see how it works on copper. I have not tried this. Let's see if all this shows up. Looks like it does. So the first thing we got to do, pardon my reach, is make sure this is on center. We'll get our little centering tool, which it's not going to reach because I put my little blocker on there. So we can fix that. So we'll just take and loosen this up and turn it around. And then that way, whoa! Flying tooling. We'll just turn this around so that we can get to it. Just make sure that it's sitting flat, which it is. Now we can get to it with our height gauge, which I know you won't be able to see, but it's all right. It's a little low, not much. Nope, too high. And a little more. And that. There we go. Call that good. Okay, so there is kind of a trick to setting this thing up, which isn't really too hard. It's just something to be aware of. So in this case, because you can, the reason this is reversible is you can turn inside radius. You can make a concave radius. So let's clean this out a little bit. Put this back. So we're going to loosen this back one too. So the deal is that you can adjust the radius. And to set that up, I'm gonna get this out of the way for right now. Just flip it down. To set that up, you put this 90 degrees to the part. And I know that's probably not going to show up very well. Let me see. Okay, so to set the radius up, put this 90 degrees to the part. You know, and just approximately in the center. At this point, it's actually not super important. What's important is that you move the X in until it lines up with the center of the part when it's 90 degrees. My head's probably going to be in the way, but that's pretty good right there. So, and then we're going to call this centered. So without moving it, let me get this a little squarer. It doesn't have to be perfect, just pretty close, because it affects where the center is. Okay, that looks pretty good. So I'm going to zero my readout. It doesn't look really square. It isn't. Hang on a minute. Let me... Okay, that's pretty good. Anyway, so I'm going to zero my readouts, and I'm not going to touch this right now. I'm not going to touch the cross slide. So I can move this, and then I'm just going to turn this, and then I'm going to slide this out until it comes over here and touches. You know, I don't think we have enough time, because anyway, that will set the radius between those 2 points. But the problem is that we don't not, and I know this isn't showing up, we don't have enough metal, so we're going to start over again. Except this time we're going to go this way, because that was my problem. I didn't go that way the first time. So we'll, until it just touches our piece. And if I'd have been prepared, I would have had an Allen wrench that fit this handy. So anyway, that touches right there. And actually, we can move it now that we've set it. As long as this stays in the same position in the holder, we're good. So I'm just going to hold this down without letting it move and snug this up. Okay, so we should be good. So we'll get it good and snug. I think we're good. We can't quite get that third set screw on it. So anyway, so now we're good. So what we're going to do is just come in here and just touch that to the end. We're going to call that our 0. So when we get to where this touches the end, we're done. Because what we'll do is we're going to actually move the X to where we're, oops. And now we're going to put our little lock stop up. Get the set screw out of the way. Chuck's in the way. So there's that. So we're going to bring this in till it just touches, and then we'll start swinging it around, and we'll just move the Y longitudinal in until we get back to our 0. So what we'll do is turn this on slow till it just touches. Which is right there. I'm bringing this in a little bit, and then we're just going to start going and see how this goes, because it may go poorly, but you'll get a good bird's eye view. So it seems to be working pretty good. So there's our good sharp insert. It seems to make all the difference. So we'll just go over, 20 thousandths at a time. Maybe a little more till we get there. Okay, we're almost done. Learned a few things along the way. One, it's much happier if it cuts from the outside towards the center instead of from the center to the outside. So I ended up zeroing off on the cross slide, so I had a reference there, where I'd already touched off, backed it out, and then I've actually moved the carriage over. I'm only 10 thousandths off on the carriage. I got 50 thousandths depth to go, but I get a far better finish. Out here was where I roughed it earlier, which is why I've figured out that this works a lot better. Anyway, so hopefully the last of it will go well. We'll find out. And I ended up dropping the RPM down to about 350. It just seemed to work better there. So we're going to go in, let's go in 15 thousandths. Just going to sneak up on this because I just don't want a bunch of chatter marks all over it. But it tends to chatter much less this direction. Plus the chips break off to the right, which keeps it out of the chuck and out of our stop. Alright, so you can see it comes to our point. That's actually pretty good. We got a couple little lines. We still have 5 thousandths off the OD to take, and hopefully we can get all the marks out doing that, and then we'll polish it up a little bit and cut it off. Let's take our last 5 thousandths. Another half. There we go. Lots of WD. And hold it steady. It really wants to chatter. Okay, I'm going to pull back on it. Stop. See what we got here. And some little, very small chatter marks. Overall, it looks pretty good. I'm going to take basically a spring pass and just see what happens. And as we get towards the end, it's not even really taking anything because it's no tool pressure down there. Okay, I'm going to call that good. Unlock the carriage and get it out of the way. So much of that you can see. Yeah, that looks pretty good. So there's it's real good here. It's got a tiny rough spot. Overall, pretty smooth. It ended up right on our groove, which is exactly where it's supposed to be. I'm going to touch the grooves lightly with a file, and then we're going to cut it off, leave it a little bit long, and then I'm going to make the other two off camera, and then once we're ready to do the other ends of these, I'll show that. It's got a really worn old Nicholson triangular file, single cut. I'm just going to use that to touch the grooves. I don't want to take much off, so I'm just going to touch them, staying way away from the chuck, being very careful. I don't want it any other place either. That'll be good. Just enough to take the little burr off. I know it's an old dull file, but the good part is that way it doesn't take much metal off, which in this case is exactly what I want. Okay, that's not too bad. Looks pretty good, feels nice. Going to just put a little piece of paper. I need some more paper. Normally I got some butcher paper I put over the bed, but it got used for something my wife's working on, so I got to get another roll. Anyway, I'm just gonna take a little 400 grit cloth and go over this real quick and see if we can't get the little chatter marks out. And a little bit of 800 grit Scotch-Brite to polish it up a little bit more. We're going to do this again after it's all done. So that looks really good. Let me zoom in on there so you can. And there we are, up close and personal, and it came out really good. There's just the chatter wasn't very much, sanded right out. A little bit in the bottom of the grooves, but we can do that later. I'm going to end up mounting these on a little arbor just to do a final sanding and polish. So all we got left to do is we're going to cut this off, making sure we leave at least 100 thousandths between the groove and the cutoff so that we have a little bit to face afterwards. We're going to end up making a sleeve that'll hold this in the chuck so that we don't leave marks on it. I have soft jaws, but I had trouble with those last time, so I'm just going to make an aluminum sleeve that goes all the way around it, and so that should work out pretty well. Let me set up the parting tool, and we'll cut this off, because that also should be pretty, hopefully not too entertaining. Big diameters of copper don't seem to cut off well, but hopefully this one's not too bad. It's still pretty good sized. Okay, we've got our parting tool in. I know that the it's all square. I did that before I set up earlier. So what we need to do is we need to make sure there's at least the width of that groove left after we cut this off. And so since we have no good reference on there, I'm just going to make sure that if I leave an 1/8, that's more than enough. I need 93, that'd be 125. I don't really need that much, but you know, the parting tool doesn't always cut perfectly square. Sometimes you get a little dish. I would rather leave a little too much than not enough. So we're going to leave an 1/8 inch. Lots and lots of lube on this, and hopefully everything is rigid enough that it will cut off without too much problem. I can always take it out and put it in the bandsaw, but I just don't want to if I don't have to. So we're going to try this. I'm going to slow it down though. I am definitely going to slow it down. Actually, I'm going to put it in low gear and turn it up a little. It's about 160 RPM. It should be good. And we'll just... It's kind of like the grooving tool. It's much happier if you keep feeding it. Right now it's cutting good. Hopefully it shows up. Tried to give a bird's eye view on this. My worry is if the copper gets too hot and expands and wants to grab the tool. So we're going to keep it really well lubricated. Keep a constant feed on it. You can see the chip curling off. Don't really want to stop if you don't have to. But I'm also not going to power feed this because it's kind of a go by feel thing right now. And sound. And here it's trying to grab on it too. I'm going to back it out, get lots more lube on our brush, and go back at it. I've got the parting blade sticking out as basically as little as I can get away with. Just enough clearance to cut it off. Assuming I measured right. I may not have, we'll see. Can always move it when it gets close. So far we're doing pretty good. We're about, looks like about 300 thousandths deep, maybe 4. Just keep it lubed and keep feeding it. Check this side here. Yeah, there's nothing building up, so that's a good thing. It's definitely chattering down at the bottom. So lots of lube, and here we go. We've got about 3/4 of an inch to go, maybe. More lube. Down to probably less than 1/2 inch left. So far okay. Let's get that chip out of there, give it some more, lots of lube. Brush actually isn't reaching the bottom, but there's so much on the sides that should be coating the tool bit pretty good. Maybe 1/4 inch. Looks like we're going to get away with it so far. All right. We do not want to let this piece drop. I can feel the warmth from the... There we go. Actually not bad. You can see where it dug in there once, where it was chattering there in the middle, but overall it came out pretty good. It broke off with almost 1/8 inch left, maybe 100 thousandths, just because of the sheer mass. This weighs I don't know, maybe a pound, a little more. So there's our first of our pieces. I'll make 2 more, and then we'll work on a little fixture to do the back side of these. Bring back later.